the first, I want you to find the place where it says weight, because the top part of your sheet, sit up and face forward. The top part of your sheet is actually something that we're going to do at the end of class if we have time right now. So please don't worry about the free fall thing. We're definitely going to do it. It's either going to be the end of class today or tomorrow. So find the box that says weight. Someone read the definition of weight for me. Go ahead, Destiny.
A measurement of how hard gravity is pulling on an object.
Great. This is confusing because you think of your weight as how much mass you have. But really that is false. Mass is the amount of matter that you have, right? The amount of how much stuff you are made up of. And weight is just how much gravity is pulling on that mass. So that brings up that you can weigh more or less on different planets. Have you ever heard that?
Yeah.
Like you'd weigh less on the moon? Yes, go ahead, Brianna.
So then why is that when I go to the doctor's office, they're telling me how much I weigh and not how much I weigh?
Right. So because all of humans currently live on Earth, we use weight as the way to track it. But if we ever get to Mars or this civilization on like a different planet, then we will probably go to mass. Yes?
So what about things like Weight Watchers? Are they trying to get things to like lower the gravity on Earth?
Yeah, so Weight Watchers is confused. Weight Watchers, when you lose weight, you're actually losing mass. Okay, you're not actually losing the amount of gravitational pull. You're losing the amount of mass that makes you up. Okay, we're gonna move on. You'd weigh less. Read that, please. Let's go. Come on, John. Hannah.
You'd weigh less on the moon than you do on Earth because the moon has less gravitational pull than Earth.
Let's think about this. Why does the moon have less gravitational pull? What is it about the moon that makes it pull on objects less, guys? Come on. If we know that gravity has to do with mass. Go ahead, Morgan.
Because it has less mass.
Right. The moon has less mass than the Earth. So you'd weigh less. Would your mass be different if you went to the moon? Yell it out.
Yeah.
No! No, listen. If here's a 5 gram rock, right? Maybe it weighs 2 pounds on Earth. If I take it to the moon, it still has a mass of 5 grams. No matter where I take the rock, the mass never changes. The gravitational pull changes. Okay, that's not in your notes. Adila?
Why do they put LV when it starts with a P?
It's because of how it's always been. Like it was some kind of old English. Okay, gravitational pull. Read it, please. Here, Myers. On your sheet. I know. Okay, thank you. Someone else. Sorry. Go ahead, Brianna.
Gravitational pull depends on how much blanket on me.
Mass an object has. How much mass an object has. Okay, so pull it. Go to the next one. Here we go. So I'm going to just talk about this really, really quickly. The moon will remain in motion in a straight line if it was not acted upon. So if the moon, right, which always looks like this. I don't know why they did this in the drawing. Always looks like this. Did not have any gravity pulling on it from Earth. It would just be flying around in space. The only reason why the moon revolves around the Earth and it's always so close to us and sticking around us is because of gravity. Because the Earth has so much gravity and because the moon is so close to the Earth. Okay? If you go like this and just put it up to the sun, which is the clock right now. If you put your hand right in front of your face and your little finger is the moon, it's so close to the Earth, let's pretend your head is the Earth,
No.
that you can't, it has to revolve around the Earth instead of the sun because it's so far away from it. Do you see the difference? Like it's very close, the moon is very close to the Earth and very far away from the sun. Okay, I'm not going to take questions on this yet. Keep on. Keep on. Oops, alright, hold on. Sorry, friends. There we go. Okay, pull it down to the next part right here. Your weight depends on how much gravity is pulling on you at the moment. You would weigh less on the moon because the moon has less gravitational pull. Now, how can we increase the force of gravity between objects? In this box, what do you think? How can you increase the force of gravity between two objects? Sherry?
You put them closer together.
Right, you put them closer together. Or what else can you do? Come on, guys. Go, Aris.
You could wait for
No. No. You could put them closer together. There are two things that gravity depends on. Go ahead, Kevin. So what could you do to the mass? Increase the mass. Good. There are two things you could do to increase the gravitational pull. Okay, pull it down a little bit. Part 2. There is a similar relationship between mass and gravity. Okay, here we go. The more mass in an object. Can you guys see this color green?
Yes.
No.
Huh?
Okay, thank you. It's the handwriting?
Yeah.
Okay. The greater the gravitational force it will exert on other objects. Let's talk about this really quick. The more mass an object has, the greater the gravitational pull. Tell your partner one example of this. Go. I don't want you to tackle this before it took way too much time. Just go back to your seat so you can talk together. Or just stand up and walk. Back to me in 3, 2, 1, and 0. Okay, no, not again. Just stay in your seat for next time. This is way too dramatic. Circle the objects below.
You told me to go walk. Didn't I do that?
No, just sit down. Thank you. You didn't do it the way that I expected you to. This is the reason why you're not going to get the stamp for today. No one else has a problem with it. Look at you. Pull it together, please. Circle the object that would have the biggest gravitational pull and put a square around the object that would have the smallest. Go ahead silently right now.
Pluto or a planet?
Yeah, I know. This is before it got switched. But I didn't say planet. I said object. Pluto is an object.
Those are planets and Pluto's not.
Okay, I'm having trouble why you're fighting with me about something so silly. Thank you. Okay, again, it says object, not planets. Just because some of them are planets doesn't mean that they all. I'm telling you, they all are. Okay, which one are you circling? Lucella? Yep. And which one are you squaring? Kaylee? There's no Venus here. Okay, look at the pictures. Which one? Pluto, good. Perfect. Which, again, like Lexi pointed out so greatly, Pluto is not any more a planet. It is just a It's called a dwarf planet. I'm not taking the question.
No, it's
It's on your paycheck now.
okay.
The closer two objects are, the greater gravitational pull they experience. Okay, number 2 you can do by yourself right now. Turn your papers over. All right, back to me. Which one, A, B, or C, will have the biggest gravitational pull? Gina? A. Why? Great. 2 things affect gravity. Let's go. We need more people. Let's go. It can't be the same people. I can't be the only one who wants you to get a stamp today. Go, Tobias. Mass and distance. Go ahead. Meaning the closer things are, the more gravity. Perfect. Number 3. On Earth, Johanna weighs 100 pounds. She calculated what her weight would be at several other locations in the solar system. The results are shown in the table below. Which of the following statements is best supported by the information on the table? What do you think? I'll give you a second to check it out. Just raise your hand when you know. Okay, Aubrey, what do you think?
B, Jupiter has more than twice the gravitational pull. The gravitational force of Earth.
Yep, that is correct. Because Earth is 100, so Jupiter is 260. That's more than twice. Everyone tracks me. So this is the part where you can get a star teammate. Okay, at the end when we go over with a couple of last questions, you guys can keep going towards your star P, but we probably have a bunch of people who haven't participated. Yeah, you guys really need to step it up in here. So if you complete the whole sheet and it's correct with your teammate, it's $1 Ganas. And you can get it in this class only. It's going to take you working hard though. The beginning of the sheet, like this top chart, you are going to be calculating your weight on different planets. Okay? You don't need a calculator for it, and you can just round to the nearest 10. For part B, you're going to follow the directions to see how far you would jump. That's where the ruler comes in. Make sure you use the centimeter side. Make sure you are not talking to other groups. You are going to have